So the first thing that we saw about derivatives is it can tell you the slope of the tangent line. That leads us to something else the first derivative can tell us. If I were to look at this little graph that they have up here, if I were to draw a tangent line anywhere on this side, my tangent line would have what type of slope? Positive, negative, or zero? Yeah, negative. If I were to draw a tangent line here, it would have a 0. Tangent line here would be a positive slope. And so if my first derivative tells me slope of the tangent line, it also tells me when I have critical numbers, because those create 0 slopes. It'll also tell me when my graph is decreasing, because it's going to give me a negative slope, or when it's increasing, it will give me a positive slope. And that's what this is telling me here. It's increasing if your y values are increasing while x is increasing. It's constant if they are the same, and it's decreasing if they're going down. And so what we can do is then we can find when a function is increasing and decreasing based on what the first derivative is doing there. If the first derivative is positive, it's increasing. If the first derivative is negative, it's decreasing. If the first derivative is 0, then it is a constant there, okay? Or the slope there is 0. And so you can actually use the first derivative to find this information. If you look at the bottom of page 175, you will see these guidelines. So then what do I do? The first thing you would do is make sure you're talking about a continuous function, all right? Make sure it's continuous on that interval that you're talking about. You want to find your critical numbers, because that's where you're going to test. So your critical numbers will tell you where there's a potential change in the graph. So like if I were to have critical numbers that tell me it's 0 there, then I can assume that there's a peak or a valley. So my increasing and decreasing could potentially change. Once I do that, I'm going to set up intervals. I'm going to start at negative infinity, and I'm going to go all the way to my first critical number. And then I'm going to go from that critical number to the next one, all the way to positive infinity, and set up these intervals. Then I'm going to pick a number in the interval. And if it's positive, I'll know the graph is increasing there. If it's negative, I'll know it's decreasing there. All right, so let's look at this example on the next page. Well, derivative test. This is what this whole thing is explaining. Your derivative test will tell you what's happening. And so for this one, this example here, I would set this first derivative equal to 0 for this little function here on the left. I would set this equal to 0, and I would find two critical numbers. I would find a critical number at 0 and a critical number at 1. That's where my changes are. And I would set up an interval from negative infinity to 0, and I would test a number in here in my first derivative. This number should be positive because this is going up. Then I would set up an interval from 0 to 1, and I would test a point in here. That point's going to show me that it's negative, it's decreasing. And then I would set up from 1 to infinity and do yet another test, and that's going to show me increasing as well. And so you can see where the slopes increasing and decreasing show you what's happening to the graph itself. So let's look at the example they give us, top of page 177. Find the relative extreme on this function in the interval 0 to 2 pi. So because this is a cyclic function, cycles, we're not going to do it for infinity. They just want it from 0 to 2 pi. So we are going to take my first derivative of this function. First derivative of 1/2 x is just 1/2. So first derivative of my sine x is just my cosine of x. And then to find my critical numbers, remember you set that equal to 0. Subtract and divide. We are looking for where the cosine of x equals 1/2. All right, where the cosine of x equals 1/2. It happens two places, right? It's going to be where I have a positive 1/2. And where does that happen? That's at my 60-degree angles, right? So my 60-degree angles are pi over 3. And then in this quadrant, it's going to be at 5 pi over 3, right? Yeah, so first and fourth quadrant for cosine. First and fourth quadrant. Yeah. So 5 pi over 3. Yeah, so those two places are where it occurs in the unit circle. And it's within my interval, right? And so for that interval, for like a cycle, we're going to set up from the beginning to the end. If it was a continuous interval, we would set it from negative infinity to positive infinity, but they don't want us to do that forever on this one. So we're going to set up from 0. So from 0 to pi over 3, when we want to see what's happening there. From pi over 3 to 5 pi over 3, we want to see what's happening there. And then from 5 pi over 3 to 2 pi, we want to see what's happening there. So normally it would not be a cycle. Normally you would go from like negative infinity to your first to your second one to infinity, and set up intervals there. But because this is a cycle, we're going to do it this way. So we need to pick a number in this interval. So when I do this, you're going to plug it back into your first derivative. You want to try to pick a number that's somewhat easy to do. They picked pi over 4, which is fine, but you want to pick something that's in between 0 and pi over 3. Okay, so pi over 6 or pi over 4. Either one will work, all right? And so
pi over 6 would be
pi over 6 is going to give you like,
1/2, right?
it's going to give you, for cosine, we had to plug back into the first derivative. First derivative, yeah. So max and min, you go back to your original. We're going to talk about how to do max and min with this as well, but for this one, you go back to your derivative. So they picked pi over 4, so we'll just do pi over 4. We're plugging it back into our first derivative. They're all going to be square roots. Yep, so we're going to say 1/2 minus the square root of 2 over 2, right? This is going to, so really, I don't even need to know what the number is. I need to know if it's positive or negative. All right? Is it positive or negative? 1 minus the square root of 2, because it already has a common denominator. It's going to be negative. Square root of 2 is bigger than 1, because I know the square root of 1 is 1, right? And the square root of 4 is 2. So somewhere between square root of 1 and square root of 4 is going to be 1 point something. So I know this is going to be negative. I actually don't even need to know what it is. I just need to know it's negative, which means this is decreasing on this interval. It's decreasing there. So if I plug in the next one, 5 pi over 3, and we pick an interval, and I think they also picked pi here, right? So from pi over 3 all the way to 5 pi over 3, anything in an interval, they just did pi, all right? And that's easy, because we have 1/2 minus the cosine of pi. Cosine of pi is what? Is -1. Well, that's going to be positive, right? Which means this is increasing here. And then we're going to do the same thing for the next interval. They did 7 pi over 4, which is going to be exactly the same, actually, as the first one, right? For this one?
So you 1/2 plus the square root of 2.
So this is just square root of 2. We're still talking cosine. So that's going to be negative, and that's going to be decreasing. All right? So then if you look at the actual graph itself, which they give you, you can see I start here, I decrease, I increase, I decrease. And so it starts giving you a mental picture of the graph itself, which is what this is doing here.
So is this all kind of...
Let's do example 4. So, for this one, we do have to do the quotient rule. Our first goal is to find the extreme, then set up intervals, and then decide what's happening to this graph, all right? So we're going to find the first derivative. Derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Simplify it. So we have 4x to the 5th minus 2x to the 5th. So minus 2x, there we go, over x to the 4th. And then we have just 2x to the 5th minus 2x all over x to the 4th. You can simplify it, take an x out, and then you can take a 2 out. So you have 2, and then you have x to the 4th minus 1 over x cubed if you reduce it. So you're going to have critical numbers whenever this is 0 and wherever it's undefined. So you actually have 3 critical numbers here, right? You have
0.
a positive and negative 1, right? And then you have 0. So it's going to be 0 at positive and negative 1. So positive 1, negative 1, and 0 are all critical numbers for this particular function, all right? So we're going to set up intervals for all of those. We're going to start at negative infinity to negative 1, from negative 1 to 0, from 0 to 1, and from 1 to infinity. You always have one more interval than you have critical numbers, all right? One more interval than you have critical numbers. And then we're going to pick a number in this and plug it back in.
I like negatives.
Yeah, it doesn't really matter which one you pick, but I try to pick the easiest one. So if there's a fraction in there, I'm going to pick one that I know is going to 0. You know, if it's a fraction of 1/2, I'm going to pick something divisible by 2, so I know that fraction gets rid of. So here I'm going to pick the smallest one that I can get away with. These two are going to be fractions, unfortunately. So I would do something like that. If you plug in a negative 2, again, I only care is it positive or negative, okay? So I look at numerator. My numerator, if I plug in a negative 2, that's going to be positive, right? Negative 2 to the 4th minus 1 times 2. The denominator is going to be negative. So this guy is going to be negative. So it's decreasing. Plug in a negative 1/2, the top. So what's happening at the top? Well, negative 1/2 to the 4th is a tiny fraction. It's like positive, what, 1/16 minus 1. So that means the numerator is going to be negative and my denominator is going to be negative. So this guy's going to be positive, right? This guy right here, I have a negative on top, right? And a positive on bottom. So this is going to be negative. And then this guy, again, is going to be the same as the this negative 1/2. So if I plug in a 2, I'm going to get a positive number, positive number. This is going to be increasing. Now, you'd think you'd know what's happening here. You'd think you just have this little wave going on based on what you see. However, right here, that was actually an undefined. And it would actually be undefined in your original function. So if you look at your graph, it's actually a break in the graph. So you do have decreasing to increasing, decreasing to increasing, but it's actually undefined here. So this is definitely not going to be a wave in the graph. You have a break in the graph there, but it still goes decreasing to increasing.
So that's